meaning for example, an abbreviation for Ontario could be and sorry, and yet another.
Funny.
Bring 20 and abbreviations to copy the data over. You might want to bring everything consistent format. You don't want to bring apples and oranges. You want to copy all the stuff over. That's one example. Second, you can go into systems very detailed table data is captured well in warehouse.
Yes, so good evening to all of you. So, how was your day today? Good, okay. So, off day, okay, Rishi. Okay, good, and yours? Yeah, me also good. It was a little bit hectic in my office. In my workplace, it was a little bit hectic, otherwise it's good. Okay, so I think it's a good strength today. 9 people are there in the class. So our today's class is on management information system. And the topics which we are covering in today's class is the data warehousing, data mining, designing database, hierarchical data model, network data model, and relational data model. So these topics are useful or are good for those people, who are having the IT knowledge or the computer software knowledge. Or if anybody of you are associated with the software industry, you will be knowing all these stuffs. So database and data warehousing, these are the terms which are very much used nowadays, because everything is data. If there is a data, you need data in every sector, you need data in every field of study, of job, anywhere you need data. So working with that data, storing that data, managing that data, extracting that data, so for that we require software technologies. So we have different software for database. We have a lot of databases available in the market, such as Oracle. We have Oracle database. Then we have DB2 database. DB2 database is the product of IBM company. So these databases are used for storing data and collecting database. And data warehouse we can say is formed of many databases. Many data, to understand in short, I'll be going in detail, but for your understanding I am telling you things in short. Many database collected at one place becomes data warehouse. Sorry, becomes. So many database collected at one place become data warehouse. So we are diving more into our today's class. Also, we are seeing some of the videos associated with data warehousing, which will give us a more clear picture. Now let us start today's class. If you have any queries, any doubts, do raise your hand or do write in the chat box. So data warehousing. Let us see it one by one. Now let us see first the difference between the database and data warehousing. So the difference is data warehousing constitutes entire information base for all time. Database constitutes real-time information. Suppose example, I go to a bank, I request the bank to open a bank account for me and my wife. Suppose what they will do, they will enter all the details, my name, my city, my address, my telephone number, my I mean, my kids' details, the type of account which I want to open, whether it's a saving account, it's a recurring account. So all those details, the bank guy will enter in the particular software which they are using in the bank. So that is the real-time information. Yes, ID. So that is the real-time information which they are entering. Suppose say you are the manager of the bank, or say Rajiv is the manager of the bank. Now Rajiv, being the manager of the bank, ask his bank guy or ask his bank employee that I want, say in the last 1 month, how many accounts has been opened by the bank. I want that particular data. Now Rajiv, since he's the bank head, so he wants all those data, that how many bank accounts are being opened in the last 1 month. So retrieving all those data, all those 1 month data, from where he'll retrieve all those data? That data will be stored in the data warehouse, which consists of the data from too many databases. And database only stores the real-time information, that right now I go to the bank, right now they enter all my information, so that is the real-time information. And having the data, 1 month data, 1 year data, 5 year data, that is the data warehouse. So data warehouse supports data management and business intelligence. So database is used to running the business. So data warehouse is how to run the business. That is the difference. It's the very important point. Database is used to run the business. Data warehouse is how to run the business. Then a producer wants to know which are our lowest and highest margin customers. Who are my customers and what products are they buying? What is the most effective distribution channel? What product promotions have the biggest impact on revenue? What impact will new product / services have on revenue and margins? Which customers are most likely to go to the competition? Now since a producer is the one who has invested the money into the project or into the film, so he wants to know all these information. Because since he has invested the money, so he wants to be sure that whether he will be making profit of that investment or not. So for that purpose, he needs all these details. Now from where he will get the details? So data everywhere, yet I can't find the data I need. Data is scattered over the network. Many versions, subtle differences. I can't get the data I need. I need an expert to get the data. I can't understand the data I found. Available data poorly documented. I can't use the data I found. Results are unexpected. Data needs to be transformed from one form to another. That means data is there, but data is not in an organized way. So, the producer requires the specific information. He requires who are my customers and what products are they buying. So he requires the specific information, but the data is not specific. Data is mixed. Data is scattered. So what is data? Now comes the concept, from here comes the concept of data warehouse. A single, complete and consistent store of data obtained from a variety of different sources, made available to end users in a way they can understand and use in a business context. So data warehouse is a place where all the data from different sources are being stored at one place, and it can be provided to the end user or to the top management, so that they can analyze on that particular data, which is useful from the business perspective. So that is database. So database is a collection of data from too many sources stored at one place. And what is data warehousing? A process of transforming that data. Data means it is not organized data, into information. Information means meaningful information, and making it available to users in a timely enough manner to make a difference. How to make a difference? that data will be provided in the format as it is being required, and data will be so that it can be helpful from business perspective. So that is data warehousing. So data warehousing means providing the data. Data warehouse is a place where all the data from different sources are being captured and stored. Data warehousing is transforming that data into a meaningful information and providing it to the users or customers or to the top management of the particular office, so that it can make a difference, so that it will help them in decision making. So that is the, so we have seen three things. We have seen database, we have seen data warehouse, we have seen data warehouse, and data warehousing. Is it clear to all? The difference between the three: database, data warehouse, and data warehousing. Okay, great. Now moving ahead. Only 3 people have replied yes. What about others? Have you all understood this? Akshita clear, Mona clear. Whenever I ask any question, I want reply from everybody. Now, data warehousing is a process. So it is a relational or multi-dimensional database management system designed to support management decision making. A data warehousing is a copy of transaction data is specifically structured for querying and reporting purpose. Techniques for assembling and managing data from various sources for the purpose of answering business questions, thus make decisions that were not previously possible. So why data warehouse is required? Data warehouse is required whenever a company wants to make reports, to analyze their performance, to predict about the future, about their future. They want the data. They want the data for the last 5 years. They want the data for the last 10 years. So based on that data, they will analyze, and it will rather help them in decision making for the company's future perspective. So for that, they want to query from the data. They want to have the data stored at one place, and not only storing, they want to retrieve the data. They want to capture the data, and they want to suppose I want to know that in 2002 how much business my company has done. Right now it is 2014, but my company is 50-year-old company. So I want to know that in 2002, in the year 2002, how much business my company has done. I want to get that data. So that's why in many companies nowadays they have a reporting team. Reporting teams develop reports, and from there where they will get reports. From there Prabha just log out and log in once again. So from where they will get reports. They will get reports through the reporting software. So reporting software can be Oracle made reporting software, or it can be IBM reporting software. There are a lot of technologies are there available in the market. Through that reporting software, they will connect that particular software to the data warehouse. They will extract the necessary information from there, and they will present that particular information in the form of reports. So we can say that data warehousing helps in management, decision making, number one. Then how? By querying and reporting. Just a second, let me put my mouse so that it will be easy for me to draw the lines. Just a second. Okay. So data warehousing helps in management decision making, then for querying and reporting, and it is a technique for assembling and managing data from okay. If I close the video player, I think all the video will get I have to upload it once again. So I have just minimized it. What is the problem with that? Are you all facing the same problem? Everybody with that video? I think this PPT is okay. Okay, great. Now coming back onto the class. So it's a technique for assembling and managing data from various sources for the purpose of answering business questions. So that is the use of data warehousing. So data warehousing is subject oriented. That means data warehousing, data that gives information about particular subject instead of about a company's ongoing operations. Number one, it's integrated. That means data that is gathered into the data warehouse from a variety of sources and merged into a coherent whole. Third, it's a time variant. All the data in the data warehouse is identified with a particular time period. Data is stable in a data warehouse. More data is added, but data is never removed. This enables management to gain a consistent picture of the business. When data warehouse is combining data from multiple and usually varied sources into one comprehensive and easily manipulated database. In common accessing system of data warehouse includes queries, analysis and reporting. Because data warehousing creates one database in the end, the number of sources can be anything you want it to be, provided the system can handle the volume of course. The final result, however, is homogeneous data which can be more easily manipulated. So these are some of the key points associated with data warehousing. One, it is subject oriented. Second, it is integrated. Third, it is time variant. Fourth, it is non-volatile. Fifth, it combines data from multiple and varied sources into one database. Then through data warehousing you can query analysis and reporting. Because since data warehouse creates one database at the end, so the number of sources can be anything you want it to be. So final result will be, you will have one homogeneous data which can be easily manipulated or work upon. So that is data warehousing. Clear to all? Any doubts? Okay. I am not getting into the history of data, otherwise it will take a lot of time. So then comes to the very important thing, that is OLTP. What is OLTP? OLTP is the online transaction processing. What is that? Special data organization, access methods and implementation methods are needed to support data warehouse queries, typically multi-dimensional queries. So OLTP systems are tuned for known transactions and workload, while workload is not known a priority in a data warehouse. So special data organization, access methods and implementation. Now what is online transactional processing? Online transaction processing are the queries which is being written. Suppose if I want to extract the data, or if I want to bring the data from data warehouse, I want the purpose meaningful data. Suppose I want the data that, suppose there is an employee in my organization called say Shahar is the employee in my organization. I want to know that in last 1 month how many calls he has made through his telephone or through his mobile phone. I want that particular data. So that data is being stored in the data warehouse. To extract that particular data from the data warehouse to my system, I need to write some programming language, some database language or some query. So that particular query which is being written is called as the online transactional processing. This is what is written here. Special data organization, access methods and implementation methods are needed to support data warehouse queries. Then let us see the difference between the OLTP versus the data warehouse. OLTP is application oriented. It is used to run business. Detailed data, current up-to-date, isolated data, clerical user, read, update, access, no data redundancy. Database size is between 100 MB to 100 GB. Transaction through is the performance metric, thousands of users managed in entirety. Now, warehouse is a subject-oriented, used to analyze business, summarized and refined snapshot data, integrated data, knowledge user, large volumes accessed at a time, mostly read, redundancy present, database size 100 GB, or probably it can be between 100 GB to few terabytes. Query throughout is a performance metric, hundreds of users managed by subjects. Now, what is the difference? We can say that OLTP is a part of warehouse. OLTP is a part of warehouse. OLTP means the data on which we are working presently. OLTP is the present data on which we are working, while warehouse stores a bulk of data. So that is the difference. Data warehouse, OLTP is a part of the warehouse. It stores the present data on which we are working, while warehouse stores a bulk amount of data or heavy amount of data. That is why it is written here that the database size in OLTP is between 100 MB to 100 GB, while in database size in warehouse is between 100 GB to few terabytes. So here the data is up to date, the data is detailed, while here there is a snapshot of data. Data is summarized and defined. It is used to run business. It is used to analyze business. It is application oriented. Why it is application oriented? Because we are working presently on the system, while it is subject oriented. Yes, Munu, we can say that. We can say that OLTP, rather we can say that OLTP is a subset of data warehouse. We can say like that. Then to summarize, OLTP systems are used to run a business, while data warehouse helps to optimize the business. That is the difference between the two. This is not very relevant. Okay. Now with this diagram I think you can understand a lot. Now this is the data warehouse. Data warehouse is at the center where all of your data are being stored. Now these are the different sources from which warehouse receives the data. Suppose this is a IT data. Say this is a finance data. Say this is a HR data. Now there are three different databases of three different business portfolios. I say suppose it stores the data of say marketing department. It stores the data of say HR department. It stores the data of finance department. Now all three data are stored in a data warehouse. What is metadata? Metadata means metadata is data of data. That is metadata. So this is the warehouse in which all the information are stored. Now these are the clients. Say this is my system. Say this is Rajiv's system, suppose. So now what we will do is we will do query and analysis. I'll let you know once I'll finish with this slide. So this is my system. Say this is Rajiv's system. What we will do is we will do query and analysis to get the data from data analysis. So data client is, what we are doing is we are writing, I think all of you have heard this name, we are writing a query language which is called as SQL. What is the full form of SQL? Sequential Query Language, to extract data on client machine from the warehouse. Do you understand? We are writing a sequential query language, that is SQL, to extract data from data warehouse to the client machine. This metadata is, yes, sequential. It has two names. We can call it a sequential query language, or we can call it a structured query language. Both the name means the same thing. The structured and sequential are the same. They are not different for SQL. Now you are talking about metadata. So metadata is data about data. Suppose I want that I should keep the backup of my warehouse. Suppose due to some reason my warehouse gets corrupted, the data gets corrupted, or due to some casualty of the warehouse, say some earthquake comes and my warehouse gets demolished. So no, metadata is not OLTP. Metadata is the data about data. That now I want the backup of my data warehouse. I want the backup of my data warehouse. So to provide the backup, I created a metadata of it. Metadata means I keep the duplicate copy of it. I keep the duplicate copy of it. Why I keep the duplicate? If something happens to my warehouse, so I have a backup of that in the form of metadata. Yes, mirroring you can say, or you can say the backup. Backup of data warehouse is metadata. Yes. It's not server, the spelling is server. Nixon. There is no word called as SURVER, it is SERVER. That's true. We are working with data which is OLTP. That's right, Munmun. We are working on the data OLTP. OLTP is the real-time data on which we are working. While data warehouse data is being only used for decision-making purposes. That is not the for analysis purpose we use the data from the warehouse data. Is it clear to all this diagram? I mean, if you understand the concept which I am telling you, it's very easy for you to understand data warehouse and databases. If you have any doubts, you can ask me right now. Now the data has been selected from various sources and then integrate and store the data in a single and particular format. So data warehouse contains current detailed data. Now it's very important to understand that data warehouse not only contains the current detailed data, but it also contains the historical data, likely and highly summarized data, and metadata. So database contains all the data. That means the current data on which we are working, the historical data, the summarized data, and the metadata. Now moving ahead. I am skipping some of the slides. Now data marts. What are data marts? So data mart is a scaled down version of a data warehouse that focuses on a particular subject area. We can say that a data mart is a subset of an organizational data store usually oriented to a specific purpose or major data subject that may be distributed to support business needs. So data marts are analytical data stores designed to focus on specific business functions for a specific community within a organization. Say data mart is a data for a finance department, or a data mart is a data for a marketing department, or a data mart data is a data for the HR department. So that are data related to particular business function are called as data mart. Lot of data marts together makes data warehouse. Okay, so data marts are the data from the respective business function. That are the data marts, called as the data marts. Collection of all those data marts at one place is called as the data warehouse. Don't get confused between the terms. Database, data mart, data warehouse, data warehousing. These all things more or less means the same thing. You can understand in one line that data warehouse is the father of all. Just to understand simply. Data warehouse is the father of all. Okay, is it clear to all? Now moving ahead. It's not confusing, Surajit. Just data warehouse is the bigger place where you dump a lot of small data. Suppose you have a big showroom, big showroom, and you brought say shoes. You have a big showroom of a shoe, and you brought shoes of different companies. You brought shoes of Nike. You brought shoes of Bata. You brought shoes of you have a different companies who manufacture shoes. Now bringing all those shoes from different places and dumping it into your showroom. Your showroom is the data warehouse, and the shoes from where you are bringing the shoes, that are the data mart. That means you are bringing the data from the data mart and dumping it into your data warehouse. Okay, now you got to know the difference between data warehouse and data mart. Just for your understanding. Now these are okay. Do you all see this particular diagram which I have drawn on the whiteboard? The bigger is this bigger box is the data warehouse, and these small box are data mart or databases. Okay, now is it clear to all? Okay, to be more specific, we can say that suppose this particular box is of HR department. Say this particular box is of marketing department. So this particular box is of finance department. So this particular box is of IT department. So data from, and this is your company as a whole, your company or organization. Do you all see this diagram? The finance which I have written here, the HR, the marketing, the IT, this is your company. Okay, great. So this is the difference between the data warehouse, data mart and database. Now moving on to the next slide. This is your data warehouse, this is your department's data, and this is your individually structured data. Okay. Now I think we'll play just one small video so that the picture will be more clear to you, I think.
Relational databases. In this video, we're going to look at a database, one that holds student information and classes information. So we'll have a list of students and a list of classes, and we'll have to combine that data in some way. For the students, we might have information.
Now this video.
This is a quick video introducing you to the fundamental concepts of databases. I'm Professor Barry Brown.
This is Minder Chen. I'm a professor of Management Information System at Martin V. Smith School of Business and Economics at CSU Channel Island. In this lecture of data warehousing and business intelligence, I'm going to talk about the architecture of data warehouse and business intelligence and compare that with online transaction processing systems database. First, let's look at where business intelligence can be used. BI can be used to improve operational efficiency by tracking, reporting our KPI, the product profitability, analyzing the risk in our operation. And we did mention like produce a lot of KPI for balanced scorecard. On the customer interaction side, we use business intelligence quite a bit to conduct sales analysis, sales forecast, segmentation of the market, try to come up with cross-selling product, apply analytics to the CRM database, and analyzing our marketing campaign and analyzing profitability across various customer segmentation. So we do ask a lot of what and why question or even how. Some belong to the online transaction processing application, like the traditional database. But some belong to data warehouse and business intelligence related application. If you ask question about a specific order, specific product items, specific customers, in terms of product inventory level for specific product, status of a customer's order, status of a customer's order, versus for data. It could be in the traditional transaction processing system. It could be flat file and Excel. What line or category contribute to the profit last quarter, and which product has the lowest gross margin, etc. That belong to business intelligence arena. This diagram showed us the architecture for data warehouse and business intelligence, and kind of the process, how the raw data migrate to data warehouse and eventually be used by the end user for analytical purpose. Step 1 over here in this diagram is the data source. We have multiple sources for data. It could be in the traditional transaction processing system. It could be flat file and Excel workbook. Can all be sources for the data which need to be integrated and consolidated and put into a specialized database, which we call data warehouse. So data warehouse conceptually is still a database, but sometimes we do use specialized database technology to handle data stored in the so-called data warehouse. Get the data into the data warehouse from multiple sources require a lot of effort. The process is called ETL: extract, transform, and load. You extract data from multiple sources. You will perform some kind of transformation to clean up the data, converting, for instance, the currency to a standard currency such as US dollar. And eventually in batch mode, we will load the data into the data warehouse. So data warehouse is enterprise-wide in nature, but sometimes, let's say the finance department or the registrar's office, like in our university, need to look at enrollment data, need to look at student payment. We may actually create a subset of the data from our data warehouse into something called data mart. So think about data mart as just like a subset of our data warehouse. And we still use kind of an ETL tool, extract, transform, and loading tool to create this data mart. And from the data mart or from the data warehouse, we can create something called cube, data cube, or OLTP cube, online analytical processing cube. The cube is kind of a conceptually a multi-dimensional data set that's derived from the data warehouse and which are ready to be used by the front-end tool. The front-end tool includes simple query tool, reporting tool, analytical analysis tool, or even data mining tool. And if you remember when we talk about Excel, we mentioned pivot table. Pivot table is an example of analytical tool that's building into Excel. We can extract data from the data warehouse into Excel's pivot table, which allowed us to analyze it in a multi-dimensional way. So this architecture gives you a kind of overview of what constitutes of the environment, the software hardware environment for data warehouse and business intelligence application. The reason we want to build a data warehouse for business intelligence application is that the online transaction, that should be online transaction processing. The online transaction processing applications database are usually fully normalized. Database normalization is one of the techniques in database design. It's particularly applicable for online transaction processing applications database. When you normalize a database, usually you have much smaller table. For instance, instead of grouping order into a single table, we have order and order detail. Instead of combining category data into product, we have a category table which is separate from the product. And this will allow us to process transaction very efficiently. If you're changing, say, the product's pricing, there's only one place in the product table which you need to worry about. However, when we try to use a fully normalized database, a lot of time for reporting purpose, for data, for analytical purpose, a lot of time we need to join multiple table, which can be a very expensive and slow process.
Now, do you understand? If you see in this particular slide, you will see that there are different source systems. Source systems are, that means you have a Word file, Excel file. You have different source systems. From that source system, you collect the data, you bring the data using the ETL tool into the data warehouse. Now, what is the ETL tool? ETL tool is the extract, transform, and load. That means extract means you are extracting the data from the source systems. You are transforming the data here. How you will transform the data? For that, there are different tools available in the market for transforming. One very renowned tool which we use for data warehousing is, or for transaction, is Informatica. Once you transform the data, you load it into the data warehouse. Further, from data warehouse, data can be bring to the data in the form of data marts using ETL tools. From data marts, cubes are formed, and that cubes will be used by the client system. How can client system use? They can use the query tools. They can run queries, SQL queries. They have reporting tools. They have analysis tools. So this is how a data is being first bring from the source system to data warehouse. Then from data warehouse, it can be accessed by the clients using reporting tools or querying tools. This is the bigger architecture, or this is the architecture of the data warehouse. This is how data moves in an organization. Is it clear to all? Any doubts, any questions, anybody? Okay. Now coming back onto the slide once again. So data warehouse is the bigger part, and data mart is the small part. So characteristics of departmental, this is we are just keeping with these slides, otherwise we will not able to cover the whole topics in the class. This we have already seen. Yes, Sumit, we are coming on to that. Just wait. It's a bigger slide. I'm just skipping some of those slides so that we can, because data warehousing, data mining, databases, these are the very, very vast topics. So we are coming on to the part which we want to look in today's class. Yes, Nixon, I can definitely break it into two classes. But actually class is already been scheduled, so what I'll do is I can, whatever topics I can cover right now, but when we schedule the class on management information system in the next month, in the month of November, so I can carry forward this particular class. This is what I can do. We can just leave it here. We can just go back onto the data models part impact. Now coming on to the database section, which we have to also see in today's class. Now what are databases? So data storage traditionally used individual unrelated files, sometimes called as flat files. In the past, each application program, in fact I can do one thing, I have the video on this database also. We can just play the video and after that we can discuss on the
Relational databases. In this video, we're going to look at our database, one that...
Hello, in this session we will talk about business intelligence component.
Fundamental concepts of databases. I'm Professor Barry Brown, Department of Computer Science at Sierra College. Databases are composed of three things:
this video on databases.
entities, attributes, and relationships between the entities. Let's talk about entities and attributes first. Here's a person. This person has a name, Bob. Bob has other attributes that describe him: his age, gender, email address, and phone number. The attributes that you choose to describe something depend upon the specific application. I'm sure you can think of dozens, if not hundreds, of other attributes to describe Bob. After all, Bob has a favorite restaurant.
Just watch this video carefully.
Shoe size, hair color, height, weight, favorite band, what he ate for breakfast this morning, mother, father, the amount of change in his pocket, bank account number, the number of songs on his iPod, and IM screen name. Do we need all those attributes? Well, some or all of them might be useful for certain situations, but let's keep it simple and limit them to the first ones that I mentioned. Because we can describe Bob with attributes that make Bob unique, Bob is an instance of an entity we shall call a person. The person entity, along with its attributes, can be used to describe many persons. Here's Sue, Frank, and Alice. They all share the same set of attributes, but the actual values may be different. Every entity needs an attribute that uniquely identifies each instance of that entity. We need to find an attribute of a person that allows us to identify each and every person separately. Such an attribute is called a primary key. The primary key attribute must be unique to every person must have one, and it cannot be shared amongst more than one person. Which of these attributes would make a good primary key? How about the person's name? After all, every person has a name, but we might end up storing information about more than one Bob or Alice. Since duplicates are not allowed, we shouldn't use the name as the primary key. Can we use an email address or phone number? Well, some people don't have an email address or their own phone number. Some people have more than one, and others share an email address or phone number among several people. So neither an email address nor a phone number make very good primary keys. If we can't find a suitable primary key among our existing attributes, we should make one. Can you think of something such as a number that every person has without duplicates? Sure. Most people have something like a social security number, driver's license number, or student ID number assigned to them. These numbers are unique to each person, and no two people have the same number. In the case of persons who don't have such a number, we could just make up a number and use it temporarily until a real number is given to them. Alternatively, we could simply assign our own numbers to each person. Many organizations do exactly this. In your wallet or purse right now are probably several ID numbers which have been given to you by various stores, institutions, and organizations. They are things like membership numbers, frequent buyer numbers, medical record numbers, and so forth. So let's do that for our person entity. Here, I've assigned the ID number 100 to Bob, 101 to Sue, 102 to Frank, and 103 to Alice. The entity in our database is stored as a table, here represented as a grid. Across the top of the grid are the name of the entity, in this case person, and each of the attributes. Each row of the table represents a specific person. Here's Bob's information in the first row. Subsequent rows have data for Sue, Frank, and Alice. A table is how we store data for an entity. The columns of the table are the attributes. The rows, also called records, are the specific instances of that entity. In this case, each row...
So here you will see that in the database, all the details in the database are, number one, it is stored in the form of tables. You see a table in front. Now, how we can uniquely identify the records? I mean, name can be same. I mean, there can be 4 persons or 2 persons with the same name, or with the same age, or even with the same email ID, or with the phone number same also. So it's very difficult to identify the different records. For that, what database will do? Database will uniquely assign one number to the particular record. That means 100, 101, 102, 103. These are the unique IDs. What is the role of the unique IDs? Unique IDs are being used to differentiate between the two records. So unique IDs are also called as primary key. What is the role of the primary key? Primary key is basically used for uniquely identify the record. That means which tells us that this is the particular key through which we can differentiate between the two records. Because name can be same also, age can be same, male can be, gender can be same, email can be same also at times, phone numbers can be same. So it's very difficult to differentiate between the two records. For that we need a unique ID or a primary key, which is being represented by the ID column here. If you see that ID column on the left hand side, so this is that unique ID, a unique key. So a table is called as entity in the database, columns are called as attributes, and rows are called as records. Is it clear to all? Okay, Nixon is saying again please. Nixon, what exactly doubt you are having? Row and column. See, row is the record. If you see that, if I want to know that, okay, I want to know about the record, I want to know about the person Bob. Now what that database will do is, I write a query, a sequential query language. What that query will do, he will go, do you understand? Is the unique ID 100. I want to fetch or know the details of the name Bob. What details I'll be getting? Okay, Bob is the person who is 19 years old, whose gender is male, whose email ID is bob@yahoo.com, whose phone number is 916-624-3333. So this is the way we extract the data from the databases. How we can extract, if I write a query Bob, suppose I want to know the information of the Bob. Now there can also be a possibility that there are two details of the same name. There can be one Bob, there can be two Bobs also. So how we can uniquely identify that particular record? For that we need a unique ID, we need a primary key, which is 100. Now I'll simply write a query that, okay, I want to fetch the details of the unique ID equals to 100. So that is the row. So row is the records. How record? If I want to know the details of the row ID 102, what data I will get? Okay, row 10 ID 2 is Frank, whose age is 31, whose gender is male, whose email ID is frank@gmail.com, whose phone number is 714-555-1212, which is the third record in the database. Coming on to the column part, if I want to know that the column existing in the database, so column, if I want to know the details of the name part, there are 4 persons in the name, 4 persons in the database with the name Bob, Sue, Frank and Alice. So those are the columns. Now columns in databases are called as attributes, tables are called as entity, and rows are called as records. Okay, clear to all? So we can say that in databases, records are stored in the form of tables.
Instances
Now I'm playing it again further.
In this case, each row represents an individual person. Let's expand our database to include information about the cars that our people own. We'll describe a car by its make and model, such as Ford and Escort. By adding 2 more attributes to each person, a person is now described by the make and model of car that they own. Bob owns a Ford Escort. Sue drives a Toyota Camry. Frank doesn't own a car. That's okay, we'll just leave those cells blank. For Alice, we have a problem. She owns 2 cars, a Honda Element and a Toyota Prius. We have a couple of options available to us. 1, we could squeeze both cars into the existing 2 cells. But that's poor form. Each cell should hold only 1 piece of information. Second, we could create another row for Alice and put 1 car into each row. But we end up duplicating Alice's personal information, and we end up duplicating her primary key, a definite no-no. The third option would be to add 2 more columns to the table. Let's rename the first 2 as Make 1 and Model 1, and add 2 more columns, Make 2 and Model 2. For those people that own only 1 car, the data about the second car will be left blank. But along comes Todd. Todd likes to fix up old classic cars. He owns 4 of them. We can expand our table to include space for 2 more cars, but then we end up with a lot of empty cells, which waste space in the table. And we're left with a real problem. What if somebody comes along who owns 8 cars? Or 20? How do we store information about people and the cars they own when we don't really know in advance how many cars they could possibly have? Taking a step back, what we're really talking about here are 2 different things, people and cars. Cars are described by a set of attributes that are different from the set of attributes that describe people. Cars and people are really 2 separate entities. A person is described by their ID, name, age, gender, email address, and phone number. A car is described by its make, model, and year. There is now a relationship between people and cars. A person is said to own cars. We will say that the cardinality between person and car is 1 to many because one person owns many cars. Many in database speak means any number of, including 0. Other cardinalities are 1 to 1 and many to many. To represent this relationship in our tables, we need to add an attribute called owner ID to the car table that establishes who owns a specific car. This kind of attribute is called a foreign key because its values are the primary keys from the person table. In a foreign key, duplicates are allowed. In fact, duplicates are necessary because the same person could own several cars. Here's Bob's car. Here is Sue's car. Frank doesn't own any cars, so his ID number doesn't appear anywhere in the car table. Alice owns 2 cars. Her ID number appears twice in the car table. And Todd owns 4 cars. His ID number shows up 4 times next to each of his cars. This is a much better way to organize the data in our database. instead of using one large table. Let's review some of the terms and concepts we covered in this video. An entity is a thing that we want to represent in a database. An attribute are things that describe an entity. Each entity is represented in a database as a table. The columns of the table are the attributes, and the rows of the table are the individual instances of that entity. A primary key is needed to uniquely identify each row of a table, and a foreign key is an attribute of one entity that refers to a primary key of another entity. Finally, the cardinality of a relationship may be one-to-one, one-to-many.
Okay, so do you understand this part, everybody? Now it is talking about the record. Now there comes the concept of primary key and the foreign key. What are primary keys and foreign keys? Suppose right now I have shown you that there are persons. Now there is a person. We are talking about Bob, Sue, Frank, Alice. Now suppose this person's we also want to store the data about the cars they are having. It's very difficult to maintain. Suppose if somebody has say one car, what are the fields related? If say have it is say if you see the first line, Bob has a car whose make is Ford and whose model is Escort. Sue has a car whose make is Toyota and model is Camry. Alice has a car whose make is Honda and model is Element. Suppose if Alice has more than 2 cars, suppose it has, okay, your Monachan is saying that another class has started. Okay, I think we can stop here and we can take up this in the next class probably and try to finish this up. Okay? What you do is you people just can go through these terms at your end also. I am typing it in the chat box. You can also go at your end and then we can discuss if required. One is data warehouse, then data mart, then data mining, then OLAP versus OLTP. Then we have relational databases. I request all of you to just go through these topics from at your end once. Data warehouse, data mining, relational databases, OLAP versus OLTP. Okay, once you go through these at your end, you can find n number of videos on youtube.com. Just go on to youtube.com and type these names and you'll find n number of videos. Just go through that video once. Then we can have a good discussion on these topics. Okay? So hope you have all enjoyed today's class. Thanks for your time. And just do give your feedbacks after the class. Take care and thank you all for your time. Bye bye.